Hello, welcome to part 11 of Learning Rust series. All right, so in this part, we're gonna code an example program using structs. To understand when we might want to use structs, let's write a program that calculates the area of a rectangle using single variables and then refactor until we're using structs. New binary project with cargo called rectangles. I'm not gonna do that. I'm just gonna do everything under Rust book from now on. Let me actually start my PowerShell as well. Go to my directory. Projects, and this directory is actually redundant. I don't have anything else about Rust down here. So I'm just going to get a cargo new Rust book. Let's do this. Well, no. Okay. Let's get into Rust book. And we get our stuff here, and I'm going to navigate to it in here as well. Let's file close folder, open folder, let me get to it. Okay. I'm actually going to go ahead and delete this projects folder. And main.rs. There we go. Okay. What are we doing? We're writing a function. Let me get to that. Function area width u32, height unsigned integers because there's no such thing as negative, dimensions. And this thing returns width times height. And then we give it some arguments. So let's w 30 and let height 50 and then print some stuff. Okay. Yeah, all the rectangle that square pixels. Comma, giving it area. And that is taking my W and H arguments. All right, let's cargo run this. The area of the rectangle is 1500 square pixels. Okay, it ran without any problems. This code succeeds in figuring out the area of the rectangle by calling the area function with each dimension, but we can do more to make this code clear and readable. The issue with this code is evident in the signature of area. The area function is supposed to calculate the area of one rectangle, but the function we wrote has two parameters. And it's not clear anywhere in our program that the parameters are related. Okay, it would be more readable and more manageable to group width and height together. We've already discussed one way we might do that in the tuple type using tuples. Let's see. So you're doing this. It gets only one parameter, which is of the tuple type. 32, 32. Okay. and then refer to these with their indexes. Index 0 times index 1. So this guy times that guy. And then you need to define a rectangle. And then call this with rect. There we go. Run that again. We got the same result. Okay. In one way, this program is better. Tuples let us add a bit of structure, and we're now passing just one argument. But in another way, this version is less clear. Tuples don't name their element, so we have to index into the parts of the tuple, making our calculation less obvious. So this is less obvious. Mixing up the width and height wouldn't matter for the area calculation, but if we want to draw the rectangle on the screen, it would matter. We would have to keep in mind that width is the tuple index 0 and height is tuple index 1. What just happened? Right. This would be even harder for someone else to figure out and keep in mind if they were to use our code. Because we haven't conveyed the meaning of our data in our code, it's now easier to introduce errors. So we just made it worse. This was a lot more clear. Refactoring with structs, adding more meaning. We use structs to add meaning by labeling the data. We can transform the tuple we're using into a struct with a name for the whole as well as names for the parts, as shown in listing 5-10. Let's write that. We still have the function area, but above the main function, we define a struct rectangle. This looks a lot like a class. Width U32 and height is of the type U32 as well. Oh, not semicolons, of course, commas. There we go. And then let rectangle 1 be a rectangle defined as such. I'm going to add a semicolon there because I forget it. And then the width is going to be 30. And height 50. Okay. Area rect 1. But then we change this, not dimensions, but to take a rectangle type. Rectangle is address of rectangle. Why is it taking the address of a rectangle? Not the thing itself. And width. Rect 1 is a rectangle. What's wrong here? Oh yeah, I need an address of operator. Address of rect 1. Passing by reference. Cargo run. 1500 square pixels. Okay. Here we've defined a struct and named it rectangle. Inside the curly brackets, we defined the fields as width and height. So right there. Both of which have type U32. Then in main, we created a particular instance of a rectangle that has width of 30 and a height of 50. 30 and 50. Well, a struct is like a class, but we haven't seen any methods implemented in a struct yet. So maybe they have those as well. I don't know. It just contains data, basically. Also, these key value pair like things remind me of dictionaries in Python. There is a map kind of pair to structs as well. Or whatever you want to call it. Our area function is now defined with one parameter, which we've named rectangle, whose type is an immutable borrow of a struct rectangle instance. Right. It's an immutable borrow. As mentioned in chapter 4, we want to borrow the struct rather than take ownership of it. This way, main retains its ownership and can continue using rect1, which is the reason we use the address of operator in the function signature and where we call the function. Yeah. So if it takes the ownership here, this function, so without this operator, you would have to return that rectangle as well to main if you want to continue using it. In this example, that's not the case, but I actually forgot to the semicolon here. Let's fix that. Okay. The area function accesses the width and height fields of the rectangle instance. Note that accessing fields of a borrowed struct instance does not move the field values, which is why you often see borrows of structs. Accessing fields of a borrowed struct instance does not move the field values, which is why you often see borrows. So this is the copy operation, or a read operation rather, not copy, right? It just reads the values of the struct, doesn't borrow it. Our function signature for area now says exactly what we mean. Calculate the area of rectangle using its width and height fields. This conveys that the width and height are related to each other, and it gives descriptive names to the values rather than using the tuple index values of 0 and 1. This is a win for clarity. Okay. Adding useful functionality with derived traits. It would be useful to be able to print an instance of rectangle while we're debugging our program and see the values for all its fields. Listing 5-11 tries using the println macro we've used in previous chapters. This won't work, however. Okay, rect1 is rect. This won't work. When we compile this code, we get an error. Rectangle doesn't implement standard format display. Oh, you need to implement something here to be formatted. The println macro can do many kinds of formatting, and by default, the curly brackets tell println to use formatting known as display output intended for direct end-user consumption. The primitive types we've seen so far implement display by default because there's only one way you'd want to show a 1 or any other primitive type to a user. But with structs, the way println should format the output is less clear because there are more display possibilities. Do you want commas or not? Do you want to print the curly brackets? Should all the fields be shown? Due to this ambiguity, Rust doesn't try to guess what we want, and structs don't have a provided implementation of display to use with println and the curly brackets placeholder. Isn't that curly braces? They use brackets, but well. If we continue reading the errors, we'll find this helpful now. The trait is not implemented for rectangle. Note, in format strings, you may be able to use that or the other thing for pretty print instead. Let's try it. The println macro call will now look like println rect is rect1. Tells println I want to use an output format called debug. debug trait enables us to print our struct in a way that is useful for developers so we can see its value. Okay, let me copy this code and paste it here. Not you. Where's my rect one? There. What's happening? Okay, yeah. We are going to use that debug formatting. Why not? Debug is not implemented for rectangle. Okay. Okay, but again, the compiler gives us a helpful note. Add derive debug to rectangle or manually implement debug for rectangle. Rust does include functionality to print out debugging information, but we have to explicitly opt in to make that functionality available for our struct. To do that, we add the outer attribute, derive debug, just before the struct definition. Okay, let's do that. Oh, down here. Oh, there, sorry. Derive, and then debug. What's going on here? Never read? What do you mean? Yes, they are. Right here. Now when we run the program, let's run it. Rect1 is rectangle, 30, right, 50. Okay, so that's what it printed. Rect1 is all the debug information. It's right here. Nice. It's not the prettiest output, but it shows the values of all the fields for this instance, which would definitely help during debugging. When we have larger structs, it's useful to have output that's a bit easier to read. In those cases, we can use that instead of this in the print line string. In this example, using style will output the following. Okay, that's nicer. Yeah, that's better. There we go. Another way to print out a value using the debug format is to use the debug macro, which takes ownership of an expression as opposed to print line, which takes a reference. I did not pass a reference here though. Okay. Prints the file and line number of where that debug macro call occurs in your code along with the resultant value of that expression. Returns ownership of the value. Calling the debug macro prints to the standard error console stream, as opposed to print line, which prints to the standard output console stream. We'll talk more about standard error and standard output in the writing error messages. Here's an example where we're interested in the value that gets assigned to the width field, as well as the value of the whole struct in rectangle 1. Derive debug, okay, with, okay, let's add these. Scale 2, and width is going to be debug 30 scale. And debug takes the reference to the struct. I think that this is incorrect. Right? It's taking a reference. No, it shouldn't be taking ownership. Can put debug around the expression 30 times scale, and because debug returns ownership of the expression's value, the width field will get the same value as if we didn't have a debug call there. Oh, this takes ownership. We don't want debug to take ownership of rect1, so we use a reference to rect1. Okay, let's see. Line numbers, that, and then rect1, rectangle. Okay. We can see the first bit of output came from source main, line 10, and its resultant value is 60. Just to print only their value, right? So this prints 60. But you also have the 30 times scale thing as well. So it prints both this expression and the 60. The debug call on line 14 of main.rs outputs the value of rectangle 1, which is the rectangle struct. This output uses the pretty debug formatting of the rectangle type. The debug macro can be really helpful when you're trying to figure out what your code is doing. Exclamation mark. In addition to the debug trait, Rust has provided a number of traits for us to use with the derive attribute that can be useful, add useful behavior to our custom types. Those traits and their behaviors are listed in Appendix C. We'll cover how to implement these traits with custom behavior as well as how to create your own traits in Chapter 10. There are also many attributes other than derive. For more information, see the attributes section. Our area function is very specific. It only computes the area of rectangles. It would be helpful to tie this behavior more closely to our rectangle struct, because it won't work with any other type. Let's look at how we can continue to refactor this code by turning area function into an area method defined on our rectangle type. So they have methods or structs. So structs are basically classes, right? This is OOP. And we're going to continue on with the method syntax in the next video.